Okay,
Yes, sir.
we are doing the different topic from the same chapter spectrum, and the new topic is electromagnetic spectrum. You know, when white light passes through a prism, we have seven colors. The band of colors, the region of colors is called spectrum. But these seven visible colors or band of colors are called visible spectrum. We call them visible spectrum because we are able to see them. They are the type of light. And light is basically a wave. We can call them visible wave or visible spectrum. So similar to those visible spectrum, there are some more spectrum which are not visible to them, to us. They are called invisible spectrum or they are called electromagnetic spectrum, whose properties are similar to those of light. There are some spectrums, the band of energy is there, whose properties are similar to the visible light. Since they do not lie in the visible range, so we will not be able to see them, but they are existing. They are called electromagnetic spectrum. If question comes, what do you mean by electromagnetic spectrum? We say the spectrums whose properties are similar to the visible light are called electromagnetic spectrum. There are actually seven spectrums, seven electromagnetic spectrums. Altogether, there are seven electromagnetic spectrums or electromagnetic waves. I will name them later, but before that, we must know the properties of those seven spectrums. What are the important or common properties to all electromagnetic? They have certain properties in common. All of them will have same properties. So what are they? First one, please write down. This is the heading: properties common to all electromagnetic spectrum. And write number one, the first one. First common property to all the electromagnetic spectrum. What are all electromagnetic spectrum? I will give the name after finishing.
Sir, you are lagging, sir.
Yes,
They all can.
you froze.
Yeah.
You are lagging, sir.
Why you're lagging?
Sorry. So your voice is
Why
very
you're
low.
lagging?
Hello, hello. No.
You are.
Why you're
So your
frozen?
voice is connected.
Hello. All it now.
You are smiling.
Sir, your sound is going.
Now it came back. No.
Yes, sir.
Now it is okay to go. Yeah, because sometimes the disturbance may take place. Okay, you can ask me to repeat, I will repeat, no problem. Because this may happen because this is a technological thing.
Oh, yeah.
First common property is, please write down number one, first one. They all can travel through vacuum. The spelling of vacuum is VACUUM. They all can travel through vacuum. Please mute yourself, please mute. Otherwise, it is echoing and we are getting disturbed. Please everyone mute. They all can travel through vacuum. Second point you write now, second common property, right? They all have equal speed. They all have equal speed in vacuum and in air. They all have equal speed in vacuum and in air, which is this value, 3 into 10 to the power of 8. 3 into 10 to the power of 8 meters per second. Done?
Yes, sir.
Yes, sir.
Third point you write, they all exhibit ESHIBIT, they all exhibit the properties of of reflection and refraction. They all exhibit the properties of reflection and refraction. That means all the electrospectrums, all of reflected and can also be refracted.
Sir, your voice is cracking, sir. Lagging.
Your voice is
No, no.
cracking. We cannot hear.
They all exhibit the properties of reflection and refraction. Have you written?
Yes, sir.
That is point number 3. Point number 4, you write, they are undeflected. They are undeflected. They are undeflected. Undeflected or unaffected, all right, or unaffected by electric field and magnetic field. They all are undeflected. They all are undeflected. They all are undeflected and or unaffected, you can write, or unaffected by electric and magnetic field. By electric and magnetic field. By electric and magnetic field. Hope we have done it. That's number 4. And you can write number 5 also if you want. They are all transverse wave. You can just mention that they all are transverse wave. They all are transverse wave. Transverse wave.
So
So
transferred.
spelling.
So spelling.
Sir, your video is freezed.
Are we there?
So
So spelling of
Hello.
trans.
Spelling.
Hello, sir.
Sir, your voice is cracking.
Someone
Sir, your
called.
voice is not cracking, but your video is
Someone
freezed.
Stop it.
Sir, your video is freezed.
Frozen.
I think he's disconnected. Someone called, sir.
Something.
They are transverse. T-R-A-N-S-V-E-R-S-E. They are transverse. They all are transverse waves. They all are transverse. T-R-A-N-S-V-E-R-S-E. They all are transverse waves. So these are the 5 properties common to all electromagnetic spectrums. In exam, they may ask you mention 2 properties which are common. You can mention the first 2, or maybe first 2. Any 2 of them you should mention. But the basic properties is the number 1 and number 2. Basic properties. And they all follow, which equation they all follow, because they are the form of waves, and all of them will follow the equation V is equal to F lambda. The last point which you have written, please write down. They all are transverse wave following the equation. They all are transverse wave following the equation V is equal to F lambda. Please write down this also.
Your voice is.
They all are transverse wave following the equation V equal to F lambda.
Excuse me, sir.
Like that.
Excuse me, sir. Excuse me, sir.
Yes. Yeah.
For the next point, no, sir, we can write they follow the equation of V is equal to F lambda.
Yeah.
Next
Last point only. Just last point which you have written. No, they all are transverse wave. Have you written that?
Sir, next point. Point
Yes,
number
sir.
6.
yes, sir.
No need to make it an extra point. They are only point number 5 only. You can write down.
And this is So what is
Point number 5, you
transverse
can
wave?
add on.
Moves in
In
a straight
class
line.
9, you have done that one. Longitudinal wave transverse, there are two types of wave. You have done in class 9. Transverse wave time, what happens? The medium particles or the vibration takes place in a direction perpendicular to the propagation of the wave, perpendiculars. So in class 9, this topic was their transverse wave and longitudinal wave. I might have done it. But anyway, they all are transverse wave following the equation V equal to F lambda. Just mention that. Okay. Their speeds are same. All of them are having same speed. And if they ask you find the ratio of their speed or ratio of their velocity in air or in vacuum, then you say 1:1 because they all have same speed, equal speed they have. Okay, now write down. Give that in complete electromagnetic spectrum. Complete electromagnetic spectrum. Number 1. As I told you that there are 7 spectrums altogether. So now I'll be naming them. So please write down. Number 1. First one is called gamma rays. Gamma rays. Second one is X-rays. You have to learn them by heart, the order. Third one is called UV. UV means ultraviolet rays, UV rays. Fourth one is visible light. Fifth one is infrared rays. Sixth one is called microwaves. And the seventh one is called radio wave. So there are altogether 7 of them, starting with the gamma, coming down. Gamma rays, X-rays, UV means ultraviolet rays, visible light, infrared rays, microwaves, radio waves. Please put them in order. And here, write down the range of the wavelength here, write down below 0.1 angstrom. The value you write down below 0.1 angstrom. A out of 0. I'll talk about angstrom. What is angstrom? I'll give the value of angstrom. Okay. The range of X-rays is 0.1 angstrom to 100 angstrom. This is the wavelength. This is the range of X-rays. Then comes UV rays will be coming 100 angstrom to 4000 angstrom. Visible light comes 4000 angstrom to 8000 angstrom. Infrared rays comes between 8000 angstrom to 10 to the power of 7 angstrom. Microwaves will come 10 to the power of 7 angstrom to 10 to the power of 11 angstrom. And the last one will come 10 to the power of 11 angstrom and above. And write down the value. 1 angstrom is 10 to the power of minus 10 meters. 1 angstrom is equal to 10 to the power of minus 10 meters. And angstrom measures wavelength. What is measured by angstroms? We say wavelength. Length of the wave in meters. The value of angstrom in meter is 10 to the power of minus 10. That is very small value it has. Okay. You must
10
know
to the power,
range
how much is
also.
angstrom?
Minus 10. 10 to the power of minus 10. 10 to the power of
Sir,
minus 10 meter.
sir, like,
And-
sir.
Yes.
Excuse me, sir. So there are no alpha,
Yeah.
alpha and beta rays.
No, not here, not in electromagnetic spectrum. Alpha, beta are not electromagnetic spectrum. Okay. About alpha, beta, and gamma, you will study the last chapter, radioactivity. Okay, there I will discuss later. Alpha, beta do not come under this category. Gamma rays, X-rays, UV rays, visible light, infrared, microwave, and radio wave. Write on one value also, 1 nanometer, nm. 1 nanometer is 10 to the power of minus 9 meter. Nm, small nm, nanometer means 10 to the power of minus 9 meter. Same value we can change in nanometer. If you change now, then you have to divide by 10. You will change this into nanometer. In nanometer, the value will come like this, below 0.01 nm. We can add nanometer. And here we'll divide by 10, both the sides. It will come same only 0.01 nanometer to 10 nanometer. 10 nanometer. This is coming 10 nanometer to 400 nanometer nm. This is coming 400 nanometer to 800 nm. Write on the value in terms of nanometer also. 800 nm will be same as 10 to the power of 6 nm. Here it will come 10 to the power of 6 nanometer to 10 to the power of 10 nanometer. And this will come 10 to the power of 10 nanometer and above. Exam time they may even ask you, give the range of X-rays. Give the range of wavelength of X-rays. Give the range of wavelength of X-rays. X-rays, the range of wavelength in angstrom or in nanometer. If they are, you can give in any one of the units, either in angstrom or in terms of nanometer. But in question comes like this: an electromagnetic wave has a wavelength of 60 angstrom, 60 angstrom. Identify the wave. Identify the electromagnetic wave or electromagnetic spectrum. Which one is that? Tell me. How will you identify?
X-ray. X-ray.
X-rays. Between 0.1 and 100 angstrom comes X-rays. You will say X-rays. Now, if question comes, an electromagnetic wave has a wavelength of 500 nm, 500 nanometer. 500 nanometer will be which one? Tell me.
Visible light.
Visible light. 500 nanometer is visible light. You can see nanometer. If you remember one way, no, like in angstrom way, if you remember, then you divide by 10, it changes into nanometer. Or if it is in nanometer given, you multiply by 10, you will get angstrom. 500 nanometer is same as 5000 angstrom. 400 nanometer will be 4000 angstrom. 20 nanometer will be 200 angstrom. If the wavelength of a wave is 40 nanometer. 40 nanometer. Which wave is that? Which electromagnetic spectrum? 40 nanometer, I'm saying. Which one it is?
UV. UV rays.
UV, yes. 40 nanometer is same as 400 angstrom. 400 angstrom, 100 to 4000 angstrom comes UV rays. You say ultraviolet rays or UV rays, you can say. Okay, understood it? Now listen.
Yes, sir.
Visible light starts from this is violet, this will go to red. What is the wavelength of violet light? 4000 angstrom, and the wavelength of the red light is 8000 angstrom. Violet has got the shortest wavelength among the visible light. Shortest wavelength violet has, and which has the highest wavelength red. Violet has got 4000 and red has got 8000, and in between other colors will be coming, in between. Just above the violet, ultra means above. Above the violet, we have ultraviolet. That's why the name is given ultraviolet. And just below the violet, which inferior to inferior to the visible light. Just below red we are having infrared. Did you understand why the name given ultraviolet and why the name given infrared? Ultra means, above.
Sorry.
Yeah, I repeat again. Ultraviolet means above the violet. Above. Ultra means above. Above the violet light, what do we have? We have got ultraviolet rays. Above it. Just see above it. Above. Infrared is the word coming from inferior to red. I mean, their wavelength is less than the wavelength of the red light. That means inferior to red, we got infrared. That's why the name is given. Just below red or inferior, just below red, we have infrared. And just above the violet, we have ultraviolet. If question comes, name two neighborhood electromagnetic spectrum to the visible light. To the visible, what are the two neighbors? One is ultraviolet, one is infrared. You understood my point, what I said?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Which is the overall, I'm not talking about visible spectrum, overall, which spectrum has the, or which wave has the shortest wavelength? Shortest wavelength, which one has shortest wavelength?
Radio waves. Gamma
Shortest
rays.
0.1, 0.1, gamma. And which has the
Gamma.
longest wavelength overall? Longest wavelength, that is radio.
Radio.
Yeah, wavelength and frequency are inversely proportional. Wavelength, shortest wavelength will have the highest frequency, and the longest wavelength will have the lowest frequency. Which has the highest frequency of all? Tell me, which has the highest frequency of all?
Gamma rays.
Gamma. I have given the order, ascending order of wavelength, but descending order of frequency, descending order. Whichever will have high frequency will contain more energy and will be more harmful and will be having more penetrating power, Which is the most harmful of them? If I ask you, which is the most harmful of them?
Gamma rays. Gamma
Say
rays.
gamma rays, because gamma rays wavelength is the shortest, so frequency is the highest, and the energy also is the highest, or highest penetrating power. Which one is the least harmful of them? Which one is the least harmful?
Radio.
Radio waves.
Radio wave, because their frequency is lowest and the wavelength is the highest, wavelength is the longest. That's why the radio wave is the least harmful of them. Now in the days of this present era, we are using communication satellites and all that. So they all are releasing radio waves. We are making use of radio waves for all our network issues, television network or mobile network and all radio waves are relayed through the stations in the space. All dish antenna all are catching radio waves, and the radio waves are since very least harmful, doesn't cause harm to us. That's why we do not mind using them. But we can't relay gamma rays in the space because this is very, very dangerous, very, very harmful. Hope you understood.
So what happens if gamma? Excuse me, sir.
Yeah, what happens?
So what happens when
Yes,
gamma
yes.
rays is penetrated to our body?
Hulk.
Gamma rays penetrates through your body, then
Yeah.
person will get a hole in the heart, person will not survive. There will be cancer. And the person's, will become blind also. Because passing through the eyes, it will damage the retina, it will tear off the retina. And person will become blind. It is very, very harmful.
I guess movies
Okay,
are
so
not.
today we are doing this much. We'll continue with the same topic on Monday. Okay, same thing we'll
Yes,
discuss. And I'll give the
sir.
properties of each one separately. Properties of the uses also. I'll talk about each of the spectrums uses also in the next class. Okay. You got 7 electromagnetic spectrum. Please learn them with the range value also. Range also. There are two ways of writing the range. We can write the range in terms of the wavelength ascending order, or in terms of the nanometer, in the ascending order of the wavelength. You got some idea. Okay. Thank you very much.
Sir.
Uh,